Hi, I am Kiran Kumar from Nature of Physics. Today's topic is impulse. When a large force work on a body for very small interval of time is called impulse or impulsive force. Simply, large force acting in short interval of time is also called impulse, student. Impulse force does not remains constant. This will be change. Impulse definition I am going to explain. The product of force and time is known as impulse, student. So, impulse is equal to force into time. That I can write I is equal to F into T, student. It is a vector quantity. It is a vector and its SI units writing, student. SI units, so force is Newton and time is second, and CGS unit, student, dyne second. And dimension formula also we can write here. dF is the dimensional formula. Force dimension formula is mLt to the power of minus 2 into time is t, student. So that we will get dimension formula is mLt to the power of minus 1 is the dimensional formula, student. Okay. And next, explaining about the momentum, student. Momentum, the product of mass and velocity is called momentum, student. So that I can write here the formula momentum which is equal to mass into time. Yes, student. Simply that is we can write P is equal to m into v. Okay, student. Then continuation, it is also a vector. It is a vector. Momentum is a vector. And SI units of the momentum is mass is kg, velocity is meter per second. And next, CGS units are gram, centimeter per second. And dimensional formula we can write same only. Impulse and momentum both have the same dimensional formula, student. Dimensional formula dF which is equal to mass is m and length is L divided by time is seconds t, student. So finally I can write mLt to the power of minus 1 is the dimensional formula of the momentum. Impulse indicated letter I and momentum represented by letter P, student. This is clear information about the impulse and momentum. And there is a relation between the impulse and momentum, student, that is taken as impulse momentum equation. Impulse is equal change in momentum. Proof I will explain. That is impulse I which is equal to delta P, student. Delta P nothing but Pf minus Pi. Okay, student. And proof for this I am using the best equation, that is impulse formula only. Impulse is equal to force into time, student. Okay. And in this F is equal to ma from the Newton's second law, student. So that impulse is equal to ma into t, student. Ma into t. Then continuation here, the basic formula, that is V is equal to U plus AT formula. V is equal to U plus AT. From this equation, V minus U is equal to AT, student, is replaced in the above equation. Okay, student. So that we will get impulse equation I which is equal to m into AT value is V minus U, student. And continuation, impulse I which is equal to mv minus mu, student. That I can write impulse is equal to final momentum minus initial momentum. Due to the initial velocity, initial momentum, due to the final velocity, final momentum, student. And impulse, which is equal to final momentum minus initial momentum. Okay, student. And finally I can write I, which is equal to delta p, student, where delta p is equal to how much, student? Pf minus pi. Like this we are getting different equations, student. Again, write according to this concept. First one is impulse formula. I is equal to, I got force into time, student. And next impulse I got m into v minus u, student. And impulse I got I is equal to delta p, student. Okay, different equations also clearly given. A, student, this is the proof 1, student, and proof 2 also is there. Wait a minute, please. Continuation I can explain here. Proof 2. In the proof 2 I am using Newton's second law formula, student. Okay, that is F is equal to ma, Newton's second law formula. In this I can write acceleration A is equal to dv by dt, student, dv by dt. And continuation here, F, which is equal to m into dv by dt, and cross multiplication is there, F into dt, which is equal to m into dv, student. And integration on both sides, integral f into dt, which is equal to integral m into dv, student. And limits from t1 time to t2 time, here velocity v1 to v2, student. And f common integral dt, that is t1 to t2, is equal to m common integral v1 to v2 into dv, student. And f, which is equal to integral dt, is t, student, t1 to t2, and integral dv is v, student, so that I can write v into v1 to v2, so that f upper limit is t2 minus lower limit is t1. Same thing here, upper limit is v2 minus lower limit is v1, student. So I got here f into delta t, which is equal to mv2 minus mv1, student, mv1. Okay, so f into delta t, which is equal to p2 minus p1, student. Due to the v1 velocity momentum is p1, due to v2 velocity momentum is p2, student. So here already we know f into delta t, which is equal to impulse, student. So that finally I is equal to p2 minus p1, student. So that I can write here I, which is equal to delta p. Clear derivation I gave you, student. This is the momentum, okay, change in momentum, that is equal to impulse. Okay, student, this is the second proof for the impulse, student. And there is a graph between the force and time. So the area under the force and time graph give the impulse, student, gives the impulse. So that here this is the graph taken. On the x-axis is time and y-axis is force taken. So the area under the force and time graph give the impulse, student. Impulse I, which is equal to area under area of f and t graph, student, f and t graph. Okay na? So that I is equal to, that is right angle triangle half into base into height, student. So that I, which is equal to half into base is time t, initial time t1 is equal to 0, final time t2 is equal to t. So total time taken from initial point to final point is t, into height is equal to f, student. So finally I can write I is equal to half into ft. This is the area under the ft graph that give the impulse, student. And another also is there condition, if average force is acting, that we can considering is the average magnitude of the force, then the equation already written, student. So that I is equal to, already I gave you impulse formula, I which is equal to, see there this equation, t1 to t2 f into dt, student. In this, force is replaced by the average force, and average force is common, that is upper limit t2 minus lower limit is t1, student. So that finally I am getting impulse with respect to average force, that is also impulse is equals average force into delta t, student. This is very clear information about the impulse. Thank you. Please do like and subscribe my channel.